Okay, and good afternoon, everyone. I hope you're doing great. I received a question that, for instance, for this specific assignment, I want to scale it up. Does it really worth or not? I always say, if you want to be in this field, especially programming AI combination, look at it as not just a project. Look at it as a kind of thing that you're gonna use as one of the things in your GitHub, and it goes in front of you to any interview saying what you're capable of, right? So if somebody asks you that, okay, can you do this, or do you have this knowledge? Technically, the best is to show that, hey, I have not only know it, but also I have done a project, and this is a video that I created, and look at the whole content. You know what I'm saying? So that would be the best approach. Let's leverage, guys. We need to finish the projects, right? Whether we want it or not, there are lots of projects that we need to finish during our staying time at George Brown. So why not we use it as best as possible, two birds, one stone, to be a part of our portfolio for future. I hope I could answer your question. But apart from it, I want to ask our friends, still I receive questions and queries about the assignments marks and so on. I told you week 1, and still I receive in week number 13 emails that, would you please consider that to mark me or not mark me, or do it this way or that way, guys. The marking of the assignments is not in my hand. Professor Maziar is the one who is kind to take care of this system. So if you have any concern, anything, please just discuss directly with Maziar. And the reason for that is very simple. Imagine that you want to run a class. If you have a colleague who needs to take care of one part and you're responsible for the other part, if they make any decision, you are not gonna override their decision. That is disrespecting the colleague, right? So I never do that. I always support my colleague. There are some parts that might need to discuss further. By all means, in those rare kind of conditions, we will sit and talk. But before that, I'm not gonna change anything. And Maziar has the highest authorization for such decisions, okay? Today's content is very much important for all of us to consider AI, machine learning, and deep learning as a potential possibility for our future. Please go to week number 13, and you can see all the files that we are gonna cover for today. You need to download them before we start working, but most of the content today, I need you to stand back, relax, and enjoy what we are doing together, okay? Everything is possible to be done on Colab, Jupyter Notebook, also PyCharm, or any other IDEs that you prefer. Again, before continuation, for those who joined us later, this is the add class code. I would be thankful if you save it for those who join us afterwards, and then share if they ask. If you can hear me clearly and everything is fine, please type 1. Matthew, Justin, Ahmed, thank you very much. So without any further delay, let's start. Thank you, everyone. I appreciate it. So let me close my camera. Okay, anyone knows these two gentlemen? You can, okay, Samuel, do you want to give it a shot and say, yeah? Yes. Lovely, yes. Um, correct. The person that looks almost towards the cam is Gary Kasparov, and the other person whose back is towards the cam is Anatoly Karpov. They were the champions back in 80s and 90s. Yes. And actually, I remember the time that I followed the news of Gary Kasparov, and I was like, wow, one day can I be like Gary Kasparov? And it was the first year that I got to, first or second year that I got to software engineering. And guess what? There was a project named Deep Blue, and Gary Kasparov was the opponent of computer. The first year, with a big margin, Gary Kasparov won the game against the computer. And next year, with a small margin, that was the first time that a machine could win a chess champion. That was Deep Blue project. That was my initial understanding of AI and how far it could get. And since then, lots of things has changed, and you can see in your everyday life the impact of AI, machine learning, deep learning. And it is very much vivid that the world was not going to be the same since ChatGPT came. You remember, it's not even 2 years that we have ChatGPT, but we almost use it frequently for many occasions. At least for me, it's like when I want to write a professional email. English is not my first language, so I always rely on something to correct me and suggest me, and ChatGPT is the best friend these days for me. So that is the beginning of AI for me. And let's just see what we are going to have for today. We are going to have a recipe like Machine Learning 101. And for that, we want to understand what machine learning is, and then the difference between apple and orange, and the definition of classifier and supervised learning. So the supervised learning recipe contains 3 phases: collecting the data, training your classifier, and then making a prediction. This is what we are going to do for this part. We are going to cover 3 different PowerPoints. This time you see mostly I focus on the PowerPoint, because understanding the concept is way more important compared to just typing the code. As I told you, there was a kind of battle between human and computer in the Deep Blue project. And that was one of the early AI. People call it that early AI, symbolic AI as well. So if you see symbolic AI, they are addressing early AI. And if you just come up with some definitions like brute force attack and so on, they just try to explain the same concept. The problem of early AI was that they were just excel in doing one task. So IBM Deep Blue was only professional in playing chess. And if you wanted to make IBM Deep Blue to do something different, you needed to write everything from the scratch. It was like basically hard coded all the steps. And that was the idea of early scientists in artificial intelligence. They thought that if we have enough regulations, we can solve any problem. But what we need is something better. We want to just have one application, one program that can solve a number of problems without forcing ourselves to write everything, to hard code everything all over again. For example, one of the things that we had in 2017 and 2018, we had a program based on machine learning. And it could, at the beginning, it was very dumb application. So it took quite a while to learn how to play Go. But after quite a while, it could play that well that it won all the champions in AlphaGo competition. The nice thing about machine learning is with minimal changes, just changing the data set, you can reuse the same application to play an Atari game, for example. Now's the time to define something as machine learning. So technically, machine learning talks about the algorithms that learn from examples and experiences instead of relying on hard-coded rules. So they need to learn by themselves with minimum human interferences. Look at the traditional versus machine learning form of programming. In traditional way of programming, we had some rules and data, and then we have some regulations here expecting to give us correct answers. Does that make sense? You might say, okay, what could be an example of such a thing? Look at this one, please. In any machine learning, in any traditional programming, let me just bring the closest, yeah, like this. Call that. Simply, if I open a new notebook, when I say A is equal to 10, when I say B is equal to 20, these are our inputs, right? When I say C is equal to A plus B, this is the process part for me. And when I say, show me the content of C, it is going to show you the result, right? So my concern is in the first two cells, we have the inputs. In the third one, we have the process part. And the last part is going to be the output for us. Guys, if it is clear, my pleasure. Please give me the first high five, type 5. Okay. Thank you very much. Appreciate it. Look at this one, but the idea in machine learning is totally different. In machine learning, you have answers, you have data, and you want computer to discover the rules for you. And now the question is why? Why should I have that demand to ask for the regulations and rules? All the things that we mostly want is having the answers. We already have answers, so why should we bother? Anybody has any reasoning rationale behind it? Can you explain why we are searching for rules out of machine learning programs? Okay, to train, to self-learn, to avoid data abuse. Okay. Very good. Thanks for contribution, Sherry, Simon, Solomon. Look at this one. Guys, most of the time, we want to have all the possible data in our data set, and answers in most of the time we have it in the last column as labels. Imagine that we have the temperature, we have the air pressure, we have the wind, we have the cloud types that we have, and we gather all this information, and we want to predict what could happen next. Is it going to rain? So could we cancel the outdoor activity that we planned initially? Could we just go for a walk or something like that? So predicting the future is something that happens based on the current data, right? So two things mostly are what we achieve from machine learning. One is predicting the future. The other thing would be understanding the status that we are in, right? You could say, okay, based on all the statistics that I have and all these parameters, I can understand why, for instance, the temperature is like that. Why? The other example is there's a kind of relationship between the amount of time that people use on their portable devices and the time that they could spend focusing on their job. So the performance has a kind of counter relation with the uh, spending time on portable devices, including phone, laptop, tablets, and so on. So how could we predict, how could we guess what could be the result of any student who spend like 6, 7 hours a day on social media, something like that, right? Okay. So by these kind of examples, we understand that why we might need machine learning. Machine learning is going to help us on predicting future or understanding the current status. Before that, we used statistical analysis models, but the problem of statistical analysis models is they could use just a small data sets. They very much relied on the human intervention, and they were very much error prone, right? Because we needed to calculate it manually. Get back to an example. Guys, imagine that we live in an era that we don't have any machine learning and we want to distinguish two fruits, like which one is apple, which one is orange. Can you please share your ideas? How can I classify apples and oranges? Would you please write some suggestions like the functions? Yeah, there are fruits. What are we going to do? So Solomon said correctly. Based on the color, Samuel said round like shape. The texture, beautiful. Yeah. Oleg said color, taste. Oleg, you're hungry. And texture and so on, size. Imagine that. Um, imagine that we just want to work on the these two things that we have right now, the trees, for example. But if you want, for instance, intentionally, I have chosen an apple that you can see there are kind of orangish color here, right? And I'm not saying it is red, but it is very much close to red because of the shadow that we have here, right? So the color could not be the only feature. The ratio, how about the ratio, for instance, the ratio of red compared to orange, right? It could be, right? For instance. By saying that, you see, we need to define all these functions like the color detection, edge detection, shape detection, texture, and all those things, correct? But there is one problem, guys. Imagine that I just change one thing. Instead of having a colory picture, if I have a black and white, or simply if I replace apple and orange with two other things like grapes and bananas, the whole things that we have, the whole functions that we define should be all written again, right? So that wouldn't be the best way to use traditional way of programming. So we need something better. We need something like the old-fashioned kind of function. So you pass some features and it can label the output for you to say if it is apple or orange. Guys, this is classifying your records, your inputs into, for this toy example, two categories, apples and oranges. Again, I'm saying you have some features, and based on those features, you're going to classify your records, your samples into different classes. That is why we call it classifier. So one of the subsidiaries of machine learning would be classifiers. When any label is engaged, we call it classification. Do we have any other type of machine learning? Oh, yeah, like clustering, like reinforcement learning. So as a kind of hello word, we always use classifiers to enter to the world of machine learning. Okay, let's go further. In this classifier, we want to see if a fruit that we pick is either apple or orange. But let me just see. Reza, you told we can use or reuse the program for something similar. What could be other examples that you want to use binary classification? Why binary? Because cat or dog, apple or orange, when you have two. So look, the other example could be an email that you receive. Could it be a mail that I want to open, or it is a spam, right? So we can see tons of examples around us that every day we use. We were not aware that there's a kind of machine learning algorithm behind it. And the thing is, to do that classification automatically is the secret behind the scene. We don't think that there is someone every day, every morning that is responsible to check our emails saying that, you know what, Reza, I think that this is a junk mail, and the other one is no, go and check it. There should be something automatic, right? So the technique to do this stuff automatically is called supervised learning. So the technique to write the classifier automatically is what we say it is supervised learning. Actually, the labels are there to supervise us if it is spam or not a spam, for example, right? For this presentation, I have planned to just write 6 lines of code that shapes our hello world and the entrance to the world of machine learning for us. As always, if you want to use any specific library, you're going to use import to bring that library, right? So you can just use Colab or Jupyter Notebook or any IDE of your choice. So we need to collect data. Imagine that we head to an orchard and we pick some random fruits, apples and oranges, I mean. So look at this. Every line that we have here, in Excel, we call them rows. in databases, we call them records. And here, mostly we say samples or examples. You can use record as well, or rows too, but that's more specific in machine learning to call them examples. So look at this one. We have 150 and the texture is bumpy. And that is orange number one. And the other example, 170, and that's bumpy two, and that's orange number two. And we have two other fruits. One is 140, the other one is 130, and the surface is smooth, and they are apples. So these are the features that we have. We could have, this is a kind of guys toy example. And in this simplest way, we have just two features. You might say, okay, is it possible to have one feature? The answer is yes, but in that case, we shouldn't bother using machine learning. We are going to write just simple if then else kind of condition, right? So we say that we have features, and the last column here is the label. Should it be necessarily the last column? No. In one of the examples that we are going to see next semester from Kaggle, and it's from Titanic Dataset. One of the columns in the middle is our target. We call them target, label, Y, dependent variable, whatever. So we have lots of names for them, but they're the same concept, right? Something that we want to predict. That's what we are sure about. So first we are going to say, look at this one. We say that, okay, we have features, guys, remember those lighter fruits that they are smooth, they're apples. So look at this, 140 smooth, it is apple. So this is the label, the output. 130 smooth apple, 150 bumpy orange, 170 bumpy orange. Does that make sense? Guys, do you see the relationship between this one, this, and then these two apples? If it is super clear till this moment, would you please give me another high five? Okay, lovely. Thank you very much. Awesome. Look at the next one. Instead of saying smooth, I just say one, and instead of bumpy, I say zero. Instead of apple, I say zero, and instead of orange, I say one. And the reason for that is in actually scikit-learn, the scikit-learn and the algorithms that we have, they are very much happy to work with numbers, not strings. So to accommodate that requirement, I just change them. And I know that one is smooth and zero is bumpy here, and zero is apple, and one is orange here. So till this moment, we have written 3 lines of code. Now it's the time for us to train our classifier. And to do so, Samuel, you can just get a screenshot from here and just see what are those things. It's not a big deal. Let me just bring that in a second. Okay. So we are going to see that in no time. Okay. And look at this one. Now it's the time for us, my pleasure, to train our classifier. And we can use many algorithms for that. And one of them is this binary classifier. And you might ask why we use binary classifier. This is one of the easiest algorithms that if you open the, if you just look under the hood, you're going to see there are just some if then else's, nothing very specific. So we can easily understand what is happening behind the scene. And we use that decision tree classifier. that binary classifier. And this time we pass, guys, remember, we had these examples. Now we close our eyes, we pick another fruit, and that fruit is 160 and bumpy. Which category do you think this fruit belongs to apples or oranges? You have the example here. Lovely, Simon, correct. Oranges, right? So it is heavier because we see that the oranges tend to be heavier and they are bumpy. So let's see if our algorithm works fine too. Just remember, because we want to use decision tree classifier, we said from scikit-learn import tree, we have those two lines without any change. And then we say, let's create a classifier. That's an object that we create based on tree.decision tree classifier, right? What is the classifier, if I may ask? That's just a box of rules. Classifier is a box of rule. Guys, if you open that box, it should give you some regulations that tell you the fruits that you have picked should be apple or orange. But guys, in line number 4, we have that box. But did we train that box? Yes or no? Did we train our classifier? Lovely. We didn't train our, I very much like Alex's answer saying not yet. So look at this one. First, let's just get to classifier's definition. It said that if we consider a classifier as a box of rules, then we can assume a learning algorithm as the procedure, and that creates those rules for us, right? It does that by finding patterns in our training data. Look at this one. Here I say, hey, go to features and labels and find patterns between them. I could say CLF equal to, or I just could say CLF dot fit, both works. So by saying that in line number 5, I say, hey, go and find the relationship between apples and oranges, right? Between the features that we have and which one makes it apple, which one makes it orange. So now we have something in our box of classifier, right? Look at the next part. We did all those steps to be able to predict. And that is the last phase, make prediction. You remember that we picked that 160 gram and bumpy. You remember 0 stands for bumpy. And if you have any doubt, look bumpy for these guys. So we want to see if it is apple 0 or if it is 1 or orange. Guys, what do you think it's going to show you? Apple 0 or 1 orange? Yeah, 1. It's going to be orange, right? Yeah, bumpy and heavier. And I told you that we are going to write one program that we can use it for several occasions. Imagine that another data set I have, and it's based on the horsepower of the engine and the number of seats. Guys, you see that if the horsepower is high and the number of seats are low, high probably we are dealing with a sport car. If the horsepower compared to those are low and the number of seats are high, we are dealing with a minivan. You see that? As simple as this. So we can just use exactly the same algorithm, exactly the same steps, and we can just, for instance, say, what about 120 and 10 seats? It is going to predict it is a minivan. The other question that we could have is, what if, Reza, I want to deal with actually the pictures and images? So these are the questions like, how does it work in the real world? How much training data we need, and how is the tree created? And what makes a feature a good feature? That's a better way of saying the last one. And I just want to show you one thing. Look at the book that we used in advanced class. Do you see that fit? And we have training data set here, and we have validation. It exactly does the same thing. So what we learned today is going to help us to apply it in any, even advanced parts. You see that it's a deep learning topic. So I intentionally saved that to show you, to see, okay, guys, it's not going to be a sophisticated thing. It's just adding a little bit here and there and make our knowledge deeper. So let's go to the other file. Everybody, would you please open the second file? If by any chance anyone wants to try any of the code here, I have provided in the previous one, I have provided all the codes in this part. So you can simply Control C, you can simply copy and paste the code. I already copied that for you in the chat. And you can just bring it to here. I'm going to tell you. And you see that it is going to predict 1. What if I say it is 110, for example, and it is a smooth number 1? This time it should predict that it is Apple by showing 0. You see that? Something like this. The file is if you go to week number 13, that's the second file, week 1302. My pleasure. I haven't worked with that, Samuel. Can you please share the link? Because there is a chance that it is makes, oh, that's what I got, I guess. So for instance, the extension is Make Sense AI. I'm going to work on that. Thank you very much to let us know. I'm going to spend time on it. And if I learn something that I could share with others, I'm going to bring it to the class. Thank you very much. So let's go to the next example that we have, and that is nothing but the classical data set that they call it iris. Iris is a type of flower, right? So everybody look at this part, and some of the things that I share with you here, you don't need to do it at the moment, and some of them are for just those friends that they want to run the code not on Colab, but on their Jupyter Notebook installed on their computer. So I'm going to skip quickly from those parts. Oh, I didn't know that. Thanks for letting me know, Alexis. Okay, so we want to see how the decision tree actually works. The whole idea of if then else's would be creating those if then else's for us, right? So if you spend time, you can create that. The whole trick is to find those borders. So for instance, in apple and orange, we want to know, okay, heavier than which threshold is going to bring us to the orange category, or to be more precise, gives higher chance to us to say that could be orange, right? So the content for now would be the type of classifiers and classical machine learning problem, which is iris, and then defining a hands-on project, and we're gonna just do that. To let you know, we have lots of machine learning algorithms. One of them is artificial neural nets, that we have some layers, some neurons. Well, actually, when we have one layer, maximum two hidden layers, we call it artificial neural networks. If you have more layers, mostly we say convolutional neural networks or deep learning. We have support vector machine, we have decision trees, we have logistic regression. You name it, we have lots of algorithms. But among them all, we are going to use decision tree for this example as well. And for the iris, let's just say why decision tree. As I told you, it's easy to understand because behind the scene, we have just some nested if then else's. And one of the few models that we can easily understand what is happening. You might say, for how about the others? I'm not saying it's not possible, but it takes lots of effort and time, for instance, to understand what is happening in convolutional neural nets. So everybody, please just search a little bit, spend 1-2 minutes and see if you can see iris data set. It should give you something like this. Huh? So spend 1-2 minutes. Okay, so can I continue if you don't mind? Okay, if you look, we could have Excel, XLS, or XLSX files, or CSV comma separated values. Or you can just go to one of these websites and drag and drop, select all of them, and just bring into any of these formats. So you see we have totally 150. Look at this one, control, and it's going to be 150. As you see, it shows 151 because the first row is the column header. So the rows could show 150, but the indices could be from 0 to 149, right? And we have 3 different categories or varieties in iris flowers. One of them is, well, they're major things. One of them is setosa, and the other one is versicolor. Let me just go down. Yes, there we go. And the last one is virginica. So the first 50 example that we have, they are setosas. And the next 50 examples are versicolors, and the last 50 examples are virginicas. You can see it here that that's the beginning of setosas, versicolors. Look at the index and the row number, index 50, and so on, and virginica. Guys, look at the column headers that we have. We just classify them based on the sepal length, sepal widths, and petal length and petal widths. If it is super clear, these are the guys, these are the features, and this is the target or label. So this is the data set that we have, and that's the label of the data set. If it is super clear, please type 3. Matthew, Kevin, Audrey, Murat. I'm gonna explain that, Simon. I haven't started that. Imagine that we are talking about this one. Okay. Till this moment. Okay, not a bad idea. Simon asked, okay, Reza, I understood these 4 columns. I understood that the labels could be setosa, virginica, versicolor, and these kind of things. But what about this? If you remember, for the apple and orange, I said the scikit-learn algorithms are happier to work with numbers. So instead of setosa, I'm going to say 0. For virginicas, I'm gonna say 1. And for versicolors, and for virginicas, I'm gonna say 2. Did I answer your concern? Okay, awesome. So by saying that, we are going to define a quick project and saying that we want to import the data set. We want to train the classifier, like using fit. You remember that from apple and orange. And then we are going to predict if I have one flower, what could be the type of that? Is it setosa? Is it virginica or versicolor? Does that make sense? Okay. And after that, we are going to see what is happening behind the scene by visualizing the tree for that. Okay. This is the part that from slide number 9, just those friends that they want to use Jupyter Notebook, they need to let me just tell you one thing from, I'm sorry, because I want to have a 5-minute break. Look at this one, I'm sorry, from slide number 19, not 9. From slide number 19 all the way to the end of slide 30-some, I'm going to tell you what is exactly the last step. Yeah, 32. These are the things that you just need to follow if you want to week number 13, Samuel. These are the slides that you just need to follow. My pleasure. If you want to just work with local Jupyter Notebook on your computer, otherwise you don't need these steps. But let me bring you back to slide number 9. Okay, so now it is 2:51. Not a bad idea to have 9 minutes break. So we are gonna continue sharp at 3 o'clock. Okay. I haven't started looking. Still, we have 1 minute. Okay, as I promised, let's start. Another file that I have provided for you guys in the same location. If you please go there, you can see that there is one file, IMDb, that's scikit-learn 2 in week number 13. Just to accelerate, I send that file in the chat as well. Plus, let me just rename this one to ease the job for you. Otherwise, you need to rename it yourself. Just give me a second. CSV. And there is one CSV file that I try just to rename it to make the job easier. Okay, so you have another file, iris.csv. And if you please open that file in the Colab and then drag and drop that CSV file iris into the files location, you need to simply click on this and drag and drop that iris file, iris.csv here. You can see something like this. So I said import pandas as PD. That's one of the important libraries like NumPy, pandas, scikit-learn. There are the libraries that we will work a lot with. And then if you double click on the CSV file, it's going to show you the content that we have over there. But that's what we saw earlier. And then we say pandas.read CSV file and place it inside a variable named myIris. And if you just say head, it's going to show you the first 5 rows. And if you say, for instance, 10, it's going to show you the first 10 rows. Or instead of head, if you say tail, and if you don't pass any parameter, it's going to show you the last 5 rows and so on. And the myIris, without saying anything, it's going to show you the first 5, the last 5, but this number is different from application to another. So you might see Jupyter Notebook, a different number of rows. It really depends on the version of the application that you have installed. But let me tell you one thing, because Iris is one of the classical examples. The scikit-learn team were kind enough to include that dataset with some other datasets in the package, so you don't need actually to have any file there. Look at this one. If I say delete the file, which I do, and I just load Iris dataset, and simply you can have the datasets, and the length of the target is 150 labels. And the features, if you say print the features, it's going to tell you sepal length, sepal widths, sepal widths based on centimeter, and the pedal lengths and widths. And what about the targets? It's going to show you that we have Setosa, versicolor, and Virginica. And then I'm going to say, hey, go to the Iris data, show me the first row. Guys, when we say 0, look at this example that I have. Do you see that in the first row, I have 5.1, 3.5, 1.4, and 2. And these numbers are exactly what you see here in the data part of the iris dataset. And look at the next part. If I say, show me the target of that, and that is going to answer again what Simon asked, if I'm not mistaken, a few minutes ago, that what is that 0? And it shows that it is setosa. So if I just say, show me the target, it's going to show you that. I'm sorry. It is setosa, which is the first index in the target names. Guys, is it clear? If everything is clear, give me the third high five, type 5. Matthew, Simon, Alexis. Great. Ahmed. Correct. Okay. Now we are going just to play around with that. We say for every I in the range of the length of the target, 150. So it's going to be what? 0 all the way to 149. Again, I would be from 0 all the way to 149. You're going to say, show us I, which is going to be, I'm sorry, which is going to stand here after the example %d. Those who have experience in programming C, they know, or Java, we have this kind of concept %d. So I is going to stand there, and %s, right? We say that the label is going to be 0, and then the features would be that vector. Do you remember that 5.1, 3.5, 1.4, and 2? Look at exactly what we have here there. I try to just make them align so you can just see. We have this one, 4.9, 4.7, 4.6, 5, and so on and so forth, right? And if you go down, it's going to get to 1. And let's just go to the first one, which is going to be 7, 3.2. So they're exactly the same data sets that we could see in any place. And now let's see what we want to do. So quickly getting back to the slides. I have already told you, we went through all these steps, loading the iris from the scikit-learn data sets, and then showing you the features names, target names, and so on. And after that, we went through showing all those elements. And then after importing the data set, we need to train a classifier. And it says that testing data. There is one thing, whenever we have limited number of samples, like here we have just 150. And imagine that we are not that much, skillful to go to nature and understand which one is setosa, which one is virginica, and so on and so forth, right? We want to train our classifier. I repeat it, we want to train our classifier. It means to find patterns between inputs and the output, the label. What can we do if we say that, hey, our classifier, our model that we provided for you is perfect, is flawless, it works fine. You can't prove it, right? Unless that you test it. So because the number of items that we have are limited, we are going to do one thing. We are going to just say, hey, apart from 150 overall data that we have, I'm going to delete 3. I'm going to put aside 3 of them. So the remainder would be 147. I use these 147 as the training data set, and I'm going to predict these 3. Guys, is it clear? I'm gonna learn from these 147 in my model, and I'm gonna test if the model that I created could predict those 3 samples correctly. That's how I'm gonna work. Guys, did you get the scenario? Okay, let me quickly ask you, everybody, how many samples do we have? Please type. How many samples do we have overall? Lovely. Thank you, Fatima. Zhao, thank you. How about this? I'm going to get rid of index number 0, delete them, put them aside in the index number 50 and index number 100. Then what would be the number of remainders? It's going to be 150 minus 3, 147. Is it clear? If it is clear, please type 1. Excellent. Merci. Great. Okay, let's go to the example that we have here. I'm going to say, you know what? Let's consider 3 of them index 0 to ease the job for you. I'm going to just bring you to this, then you can easily see. I'm going to say that iris, here it is. I'm going to say that the test indices would be index 0, 50, and 100. You remember, index 0, 50, and 100. And then I'm gonna say the iris.data would be, if you pass 0, it's going to give you guys, everybody now remembers that it's 5.1, 3.5, 1.4, and so these are going to be the data of those 3. If you have any hesitation, you can simply see, for instance, the last one is 6.3, 3.3, 6, and 2.5, sorry. And then this one is the second 7, 3.2, 4.7, and 1.4. And the first one, everybody remembers that. And how about the indices? Very simple. Simon asked that question. What are those? Remember? So 0, 1, and 2. And then we are going to use NumPy because we are gonna use some commands that they are in the NumPy library, like delete those indices. We say that go to the target and delete these green things like this one, and this one, the labels. Here we say go to the iris target, the green ones, and say delete those indices. How about the next one? In the next one, I say go to the train target and delete those yellow parts. Look at this. Delete this one, and this one, Okay, everybody, you got that? So technically, the training data now has 147, and the test data has those 3 rows that we deleted from there. Does that make sense? If it is clear, please this time type 3. Thank you, Matthew, Alexis, Zhao. Okay, go through those lines at your convenience. Michael, thank you. But they're not that difficult, very simple. We just deleted those 3 rows, index 0, index 50, and index 100. In the overall data set, we have 150, but we deleted those 3. Okay, now I want you to do me a favor, everybody. If I say print the test target, guys, do you know is this based on calculations, or it just checks the target of those 3 deleted records? Is it based on calculations, or it is already there? Can you please tell me? They are the targets that are already there. We don't do any calculations or predictions, right? We had those 3 rows. We said that, okay, print for me the test target, which is going to the iris dot targets those 3 indices. We already have them. Guys, is it clear? I checked index 1, index 0, index 50, and index 100. Is it clear? Guys, it's not difficult. Just I want to double check that if you focus. Look at this one. I just say, go to the iris target and pick those test indices, and they are going to be the test targets, which is going to be 0, 1, 2. Here I just say print them. So it's going to be 0, 1, 2, right? If you understand that part, please type 5. Fatima, thank you. Matthew, Daniel, Alexis. Okay. How about this one? I say, what if I give you the data? What if I give you the yellow part and I want you to predict what could be the answer? This time I give you the test data, guys, not the label part. I give you the test data. And I want you to predict what would be the answer. Look, the results are the same. We are lucky. The labels, the actual labels were 0, 1, 2, and the predictions were 0, 1, 2. What is the accuracy of the algorithm that we used? Lovely. It is 100% because whatever we had here as the ground truth, original labels, y, was exactly equal to what our prediction, our y prime, or the output of the algorithms show. If here, because we had 3 labels and 3 predictions, and we could say 3 correct predictions, we say it is equal to this one divided by, we say that this one divided by the overall multiply 100. So it's going to be 100%. What if I had 2 correct precisions? Then it would be 66 point, it would be 66.67, the overall precision. Does that make sense? Okay, spend a few seconds, go through it, and get all the way to this part. And if you can understand it, then please type 1, but spend a few seconds. Thank you, Alexis. Joao, Matthew, Fatima. Okay, One quick thing, because the visualization part is not the part that I want to emphasize for today, and you just want to use it, I'm sorry. Go to the, did I miss? Yes, I missed a lot of things, so I need to go all the way up from here. Yeah. Okay, so if you're on that, it takes a few seconds for you that you're gonna see there will be a file here, and you can simply download that file. But let me just go a little bit further. And if you see that here, it says that download the file. Please go to the next one. And I created another one, and that is Iris 2 PDF, and we download the file. What I want you to do, let me just bring it to the desktop. There we go. If you open the file, it is going to show you something like this. Everybody, would you please just go through the stuff and create this graph that's a colorful. The first one is black and white, but this one is colory. Take your time. Whenever you are done, it's going to provide for you something like this. Then please type 2 to confirm that you have similar result. Thank you. That is the black and white one, the first one, Alexis. Please continue. That is this one. But the other one should be colory. Well, they're just different libraries. You see that here is the colory one, which is the corner. Continue. You're gonna just see the second one provides the rounded corner. Okay. So those who could finish and see this graph like this, please type 2. Awesome, Alexis, Matthew, thank you. Now look at the data set, and that is the overall thing. This is the decision tree that machine learning provided for us. And let's see how it works. The first condition says pedal widths. If the pedal widths, guys, what is the pedal widths? Here is the pedal widths. If the pedal widths is less than 0.8, which is for the first one, then we go to the leaf and it says that it is setosa. Is it clear? So with just one check for the first one, we got it correct. It is setosa, right? Let's try the second one together. Let's go to this example. So here, guys, what is the pedal widths? It is 1.4. Is 1.4 less than 0.8? No. So the false state is the right one. We go here. How about the pedal widths? Again, we check it. Is it less than or equal 1.75? Yes. Then we go to the left side. And here we check another feature, and that is this one. petal length. If you have any doubt, look, it is petal length. So in here is 4.7, less than 4.95, yes. So the true condition is triggered. We go to the left side. And then we check petal width again. This one is 1.4, less than 1.65. The answer is yes. We get to the leaf, and then this is versicolor, which is totally correct. The last example, I leave it to you. So please go through these conditions and check it, how you can get to the correct answer, Virginica. Okay? By saying that, we pretty much covered what I wanted to tell about this part, and we quickly go to the easiest slides among the one that we covered today, and that is slide number 3. Guys, if you could relate to what I said and everything made sense, I'm not saying that you could grab 100%. If you could follow what I said, the concept, please give me the force high five. Thank you, Hamed, Fatima, Simon, Matthew, Sherry, Michael, Justin. Okay, Solomon. Look at this one. Now, the question that we asked in the first PowerPoint in today, I asked you what makes features good features. And Josh Gordon, the one that I owe him a lot to understand the machine learning and deep learning, has a nice quote. He says, classifiers are only as good as the features you provide. So Audrey said, what was the method to see all the rules a model has gained? You mean the tree view, Audrey? The visualization? Okay. That is beyond the scope of today. I just wanted to show you it needs actually deserve to have something like 4 hours for that. So we just skimmed this part, and that is why I didn't. But if you want to just go deeper, that is the pie plot. We import PyDots plus, and we import ipython.display. Okay, that's a good question, and I quickly answer that. But for the more precise answer, we need to wait till we learn more libraries in the next semester. We have a project and assignment. There is no yes or no or short answer to that. But look at the example that we have gone through a few. Let me just bring that again. Do you remember the example that we had, and it was like apple and orange? Let me just bring you here. Apple and orange, you remember that, Audrey? So we had some labels here, right? Technically, we break the data set into 2 parts. Imagine that you have 100 rows. You are gonna pick 80 rows to train, and you leave 20 aside to test. And among those 20, you are gonna see, okay, how many of them you could correctly predict their labels, right? If you could predict something like 15 out of 20, you multiply that by 5, right? Because the overall is 100, then you are going to say 75% were predicted correctly. Did I answer your concern? So you have part of the data set aside to test. That is how you're going to see how your learning works. But this is not a quick topic just to cover. If I can just show you another PDF, I closed it, that I talked to, that's the kind of advanced topic that we covered today. I think that I have that. Yes. Look at this one. You see that we have validation, we have the training, and we have a test portion. So based on the validation and based on the test, we can see how accurate our model is. And for instance, in here, the prediction that we have and the actual data that we have in hand, they go the same tendency, but we are not always lucky like that. Look at this one. So this one shows that the data in hand that we have works perfectly fine. The accuracy is almost 100, but the real accuracy with unseen data that we do not have it in our hand is something like 70%. And actually, this 70% is the real number. I hope that I could answer your concern as briefly as possible, but I could just make the point. Okay, let's go to the next example. And we are going to see the binary classification. And here we want to work with something familiar. We want to work with two breeds of the dogs instead of apple and orange example that we had. Now we want to work on two breeds of the dogs, greyhounds and labs. And we want to see, based on the features that we have, which dog is greyhound and which dog is Labrador. And among all the features that we have, we pick two features. One is their height and one is their eye color. And I want to emphasize that these are just fabricated examples. So if you see that they're not very accurate, we just want to show you how this works, okay? We consider that greyhounds are almost 4 inches taller. So they are 28 inches tall, while in average, Labradors are 24 inches tall. Let me ask you one thing. Imagine that the eye colors that we have in our dogs and groups, they are either blue or brown, regardless of breed of the dogs. They are 50% blue, 50% brown. Guys, what are we going to choose then? We have heights and we have eye colors. I'm asking you not based on the artificial intelligence or machine learning point of view. In general, if a dog is taller, could we say that the chance of being in the greyhound category is higher, yes or no? Okay, Audrey, I don't see your answer. What is your opinion? Okay, good. How about the others? Guys, look. Uh-huh. Okay. How about the eye color? Guys, I repeat my sentence, regardless of breed of the dog, the chance of being Labrador and Greyhound is 50-50. So if you just bring a dog and see that the eyes are blue, it could be Labrador 50% and it could be Greyhound 50%. Do you think that eye color is informative? Yes or no? Technically, it is useless, right? But let's go further. Many a time, especially for the university level, we do not have access to the real data sets. It is not easy to find actual data sets. So we, I'm sorry, we create the data set based on some assumptions. So here we are going to do the same thing. Imagine that when we talk about greyhounds and labs, we deal with different variety of greyhounds and labs. And here we want to generate 500 greyhounds and 500 Labradors. We say that the greyhounds are 28 plus, well, technically when we say numpy.random.rand n, that is the normal random, which the center would be 0, but it's going to be plus minus 4-ish. And it's going to be for Labradors 24 plus minus 4-ish, because it's again normalized random. How many of them? 500, I'm sorry, 500 of these two. And then based on that dummy data set that we created, we fabricated, we are gonna plot the Greyhound and Labradors, and we are going to consider for Greyhounds red, and for Labradors we are gonna consider blue color, and we stack them on top of each other and we show, and it's going to show you something like this. And you have the code, you can try it. You have the code in the note part of this, and it's going to show you something like this. Or if you use Jupyter Notebook, it's going to show you something similar to this one. I'm saying similar because it's random normalized form. And you see that here you have a graph based on 500 greyhounds and 500 labs. And remember, the left side are labs, those blue colors, and the right side are greyhounds. Can we say that greyhounds are taller, the reds are in the taller towards 40 inches, these ones are shorter? We can see that. Okay, everybody, here, can I say with almost 75% in this column, can I say with 75%, the dog that I pick, I could say should be Labrador, yes or no? Blues are Labradors. And I'm saying roughly 75%. You might say, no, it is 80. You might say it is 70. I'm just saying roughly. Thank you, Sherry. Can I say with high confidence, I could say in this, if a dog is, for instance, 18 inches tall, high probably it is Labrador. And if it is, for instance, 36 inches, it should be Greyhound, high probably. Guys, is it correct? If correct, please type 1. It's not a trick question intuitively. And if it is not correct, please type 2. Okay, awesome, thank you. But the problem, the real problem, is for the middle columns, for these columns. Can we confidently say that, for instance, if it is 27, it is Greyhound, or if it is Lab? We don't have that confidence for the middle. So it talks about the same things. So what can we just bring those eye colors, say that, okay, you know what, in the middle, let's check the eye color, and it's going to add any extra knowledge to our data set? Yes or no? I repeat the question. Considering the eye color, which is 50-50 regardless of the breed of the dog, is it going to give us any further information? Lovely. Everybody said no, and it is not informative. So guys, if you want, and that is actually what in the next semester you're going to create one simple data set yourself, what could be the features that you could come up with to say, okay, these are better features to distinguish between greyhounds and Labradors? And any dogs, what are the features that comes to our mind? Lovely. Hair type, awesome. Tail length, bravo. Ear size or ear shape, if it is pointy or, right? What else? Leg size, bravo. Maybe some colors are more dominant in one type, or right? Or how about the speed of the dog? How about the weight? Bravo. So if you just think about that, you could come up with these features or even way more, like the hair type, the hair length, the speed, the weight, and so on. But definitely based on what we said, the eye color is not going to bring any value to ourselves. Behavior is very much hard to measure, Alexis. I would love to see how people could just convert behavior into something numeric that we can just bring into engineering. But I have no idea about that. For instance, people say that Labradors are super friendly. So how about just having some measurement for that? But I'm talking about, yeah. Okay, so let's go to the next. The first thing that I want you to remember is the information that we are going to have should be informative, right? Um, yeah, awesome, Alexis. Guys, so the information should be informative. So we are gonna toss away the features that are not gonna give us any information. One quick question just came, it came to my mind. How about converting inches into centimeter, and then we have two columns to use? Guys, is it useful, you think? I'm gonna say useful, or is it going to be useless, or is it going to be harmful? What do you think? Is it going to be, guys, this is not a trivial question. It's not a simple question. So think about it. Is it going to be useful? Is it going to be useless? Or is it, and let me just ease the job. So useful and capital. So instead of that, say U. And for useless, and what is the other one? Harmful. So I'm sorry. I think that this is going to be easier for you to use this. Is it going to be useful? So please type U, L, or H. So Fatima says it is useful to have another column based on centimeter. We convert that. And Sivan is saying it is useless. So we have UL. How about the others? Guys, the only wrong answer is the one that you keep and not share. We just want to do brainstorming. So some people say useless, useful. Useful, useful. Okay. Let me ease the job for you. Okay. We have something that it is very certain, and you can see it in the next slide. Independent features are the best. Guys, whenever you convert inches into centimeter, you don't add any value. You already received credit for that. Does that make sense? If I repeat it, if you say the height based on centimeter, you actually have that height with different measurement system. Is it going to give you any graph different from what we saw a few seconds ago? So no, right? It's going to be the same. It's going to be the same graph. Just the numbers are going to be different, but the same graph. So now, so we see that it is not useful, but the question is it useless or is it harmful? And surprisingly enough, it is harmful, because some of the algorithms are not wise enough to understand that you have already received a credit for that. So they're going to just give another credit for it, right? And that is not correct. So in that case, they're gonna use it. It gives extra. They give extra credit to something that you have already received. So it is harmful. We have something that they call it coefficient matrix, and that's beyond the scope of that today's session. But we check if they are independent enough, and we have a ratio for that. So the question is, are we have height in inches? Would it be useful, helpful? No, it's going to be harmful, right? And the conclusion could be avoid redundant features. Okay, can you just convert the graph? Is it going to give you anything new? Is it going to give you anything informative? That's a question that should be answered. Now, the last thing, guys, I try to just cover the last part without asking you to stay more. So let me ask you one thing. Imagine that you have the estimation that from Vancouver, if you want to send a package to Toronto or from Toronto to Vancouver, it takes 3 days using, for instance, Amazon. I'm saying, right? And you want to calculate how much time you need to send similar to Montreal. Okay, so guys, is it clear, the question? Based on the distance that I have between Toronto to Vancouver, I want to have estimation from Toronto to Montreal. Is the question clear? If yes, please type 1. Okay, now the question for you is, guys, which one do you think the best for calculating the estimation? Do you think that the direct or the flight kind of path would be the best, or the coordination? So the Google distance or the coordinations, which one is the best? Distance D, coordination C. Which one do you think is the best to pick the feature? You have both of them. Which one do you feel would be the best? Again, the wrong answer is the one that we keep. Oleg says coordination. Okay, awesome. Who else? Ahmed, coordination. Coordination. Maria, thank you. Thank you very much. Okay, let me tell you one thing, guys. One simple question. If I give you this, I say between Toronto and Vancouver, we have 2,500 miles. Which one is easier for you to understand? This one or this one? The coordinates or the distance? Which one easier? Okay, lovely. Excellent. So actually, that is how computer works as well. For computer, it takes lots of effort to understand, okay, I have those numbers. What should I do with them? Should I just subtract them? Should I do what? But this one is very easy if you have that one column for the distance. So it is easier for computers. If you have a chance without sacrificing anything, if you have two features, please pick the one which is easier to understand, right? Yeah. And so simpler relationships are easier to learn. If I want to summarize today's session and the ideal features, and please, I repeat that the MCQ questions I checked with ChatGPT, and they do not provide correct answers. Look at this one. They should be informative, the features, they should be independent, and they should be simple, right? I repeat it. The features that we need to have, they should be informative, independent, and simple. And by saying that, we are done with today's content. Thank you very much. And I hope you enjoyed today's session. Now it is 3:50. I could finish it right on time. Have a wonderful one. If you have any concern, any question, then in the lab, you're gonna just work on more examples, and Maziar is going to help you to understand. Thank you. Have a wonderful one. Take care of yourself, guys. Ciao. Bye.